we are going to discuss about the solution of an important problem from the successive differentiation. Okay, and the problem is of type if y this is equal to sine of m cos inverse root x, prove that limit x tends to 0 yn plus 1 by yn this is equal to 4n square minus n square by 4n plus 2. Okay, and we know that at this type of problem we use the successive differentiation of Leibniz rule or Leibniz rule of successive derivative. And what is Leibniz rule? Leibniz rule says that the nth derivative of uv, this the product of two functions, here u and v we say, and here we let u be the first function and v be the second function. Okay, then this rule gives un, this is the n times derivative of u into v, plus nc1 un minus 1 into v1, this is v1. So the derivative of first function is 1 times less than the previous term and the second function is 1 times greater than, and so on. Okay, this is the Leibniz rule. Now we first differentiate the term y. Differentiate the term y with respect to x and we get the result as y1 this is equal to cos of m into the differentiation of m cos inverse root x is given by m by root over 1 minus root x square, this is x, and 1 minus is also because the derivative of cos inverse is minus 1 by root over 1 minus x square into the derivative of root x 1 by 2 root x. Right, now squaring both sides we get 4x into 1 minus x. We multiply this term here in the left side y1 and this is m square cos square m cos inverse root x, and this can be written as m square into 1 minus sine square m cos inverse root x. Right, so we get this is m square into 1 minus y square. So 4 into x minus x square into y1 is equal to this. Now differentiate one more times with respect to x again. We get 4 into 1 minus 2x into y1 plus 4 into x minus x square into y2, and the right side is minus 2 into. Now we differentiate this expression once again with respect to x and getting the result as 4 into x minus x square into 2 y1 y2 plus 4 into 1 minus 2x into y1 square. This is equal to m square into minus 2y into y1. Okay, this is the first derivative of this line, and we cancelling from both sides 2 into y1 and write all the expression in left side and getting the result as 4 into x minus x square into this is y2 because 2 y1 cancel out. Here we get this is equal to 2 into 1 minus 2x into y1 plus this is m square into y, this is equal to 0. Now we use here Leibniz rule of successive differentiation. Now by using Leibniz rule we write first this is dn 4x minus x square y2 plus dn 2 into 1 minus 2x into y1 plus dn m square into y, this is equal to 0. Okay, and using Leibniz rule we get here we take this is the first function and this is second function. So we get the result as x minus x square into yn plus 2 plus nc1, the derivative of y2 here less than the 1 times less than the first term, so this is yn plus 1 and the derivative of this is 1 minus 2x. Now nc2, this is yn and derivative of this term again minus 2 and all the other term are 0. We write this, and the second term, for the second term we take common here 2, this is 4 outside the bracket. Okay, 2 outside the bracket, and the first term is here y1 and this is the second term, so 1 minus 2x into yn plus 1 plus nc1. The derivative of first term is yn because 1 times less than this, and the derivative of this 1 times is minus 2, and all the other term are 0, plus the derivative of this is simple, m square into yn, this is equal to 0. Now we have to find the value of limit x tends to 0 yn plus 1 by yn. So we put simply both sides, or this expression is x equal to 0. So put x equal to 0, we get the relation as 4 into this term totally becomes 0 because this is 0 minus 0, so 0, and this term is, so this is 0 starting with 0, and this is nc1 means n, this is 1 minus 0, this is yn plus 1 at 0, minus nc2 minus 2 into nc2, so nc2 means n into n minus 1 by 2 into yn at 0. Now for the second term, this is 2 into, this is 1 minus 0 yn plus 1 at 0 plus, this is minus 2n yn at 0, and this is the second term, so all the other term are 0, we cannot write this, and m square yn at 0, this is equal to 0. Okay, now we write at first yn plus 1 0 in together, and this gives 4n, because 4n minus here also yn plus 1 at 0, this is 2, so this is plus 2, and yn plus 1 at 0, this is the first term, and the yn at 0 is given by 4 into, so we get minus, taking common minus, this is 4 into n minus 1 minus yn at 0, and this is also minus 4n, so we get plus 4n because we take common minus, and this is plus, this is minus m square into yn at 0, this is equal to 0. Okay, now this result gives 4n plus 2 yn plus 1 at 0 minus, this is 4n square minus 4n plus 4n minus n square, this is yn at 0, so this is 0. Okay, and minus 4n plus 4n cancel out, so we write the result as yn plus 1 at 0 by, term is given by 4n plus 2 in the lower position, and in the upper position this is 4n square minus m square. Okay, and this term is also written as limit x tends to 0 yn plus 1 by yn, this is equal to 4n square minus m square by 4n plus 2. Okay, and this is our required result. Right, very simple problem, but we use here the Leibniz rule, and It is very careful when we use Leibniz rule of successive differentiation. Okay, thank you for watching.